All right, November 13th. So, this talks about all this stuff. Basically, the difference here is that if we have an infinite discontinuity inside of our interval, so as you look here, you can see that we have a problem here. We have an infinite discontinuity at x equals 3. So we're going to do something similar to what we did in the previous lesson where we let it approach infinity, except we need to approach 3, and we need to think about where it's okay. It's okay up to 3, less than 3. So we need to approach 3 from the left. So we're going to take the limit, okay, as b approaches 3 from the left. And then our integral is going to be from 0 to b, and I'm going to rewrite that. And this one's a little bit trickier because it's minus x instead of x minus 3. So that's going to be negative 1/2 dx. So hopefully we're pretty experienced calculus students by now after a year and a quarter. So the trick here is, if that was reversed, I could just use the power rule, basically add 1 to the power and add 1 to the exponent, divide by the new exponent. But here, if you think about it, if we were to do a u substitution, du would be negative. So we just need to make sure that we include that negative when we integrate. So when we integrate, that's going to be negative because of that. And then add 1 to the exponent, so that'd be positive 1/2, divide by the new exponent, so dividing by 1/2 is like multiplying by 2, so we would get that, and this is going to be 3 minus x to the 1/2, or the square root of that whole thing. And then that's going to be from 0 to b. Okay? Glad I realized to move that up before it disappeared off the screen. And you should read that stuff up there. I just didn't think I don't think it's worth your time to have me read it to you. You should be able to read that yourself. And if you have any questions, ask me in class. All right. So if we plug in those b's now, so one more time, the limit b approaches 3 from the left. So that's going to be negative 2 times the square root of 3 minus b. And then it would be minus 2 and the square root of 3 minus 0. Okay. So that part, all right, so that's fine. So now if we do some numerical analysis and we plug in 2.99999, and this is going to be plus 2 root 3. So that's going to be really tiny, 0, 0, 0, and so that's going to be 0. And so our integral is going to be 2 root 3. Okay. So hopefully that worked out for everybody. Now, this one is kind of double trouble. So we've got that infinite discontinuity at 3 again, but that's on the interior here. So, excuse me, we're going to have to divide that up, first of all, and go from 0 to 3. And then go from 3 to 4, because we have a problem on both sides of that. Okay, so let's do this side first and see what happens there. It's already telling us that it diverges, so one of these is going to diverge. So I'm just going to start with this one, and if that one diverges, then I don't have to do that half. If this one doesn't, if this one goes to value, then I would have to do this one, and because of the directions, then I would expect that one to diverge. But let's see. So we're going to take same thing we did over here. So the limit as b approaches 3, and this is the left side over here. So I'm going to integrate that. So add 1 to the exponent, divide by the new exponent, and then that's going to be from 0 to b. Alright, so let's write that limit down one more time. And then if we plug b in there, that's going to be -1 over b minus 3. Okay, and then here, that's going to be minus a minus. Obviously, we could just put plus, but in the notes, I want it to be a little more clear. So it'd be minus, and then minus. And this will be 1 over 0 minus 3. Okay, so 2.99, so it's going to be -1, 2.99 dot dot dot, minus 3. That'll be plus, but then that's a negative, so that's -1/3. So that looks good, but we got to look over here. This is going to be -1 over -0.000 dot dot dot, numerical analysis. So that's going to be infinity. So that diverges. Okay. So we don't need to evaluate the second integral because it already diverges, so there's no point. Alright, so yours probably looks a little different. Maybe you have this up here, but it's the same page. Just check the example. So here we're going to have an infinite discontinuity at -1. So we need to split this up at -1. I kind of would like to skip a step there and just go straight to the limit. So the limit would be as b approaches -1 from the left. Okay. And we're going to, that would be to the -2/3 power. So we're going to add 1 to the exponent. So that's going to be x plus 1 to the 1/3. Because it'd be -2/3 if we rewrote that. So add 1 to -2/3 and you get 1/3, and then divide by the new exponent. So that would be 3. And then our limits of integration would be -2 to b. Alright. So if we needed to, we could come up here and rewrite this as two integrals, dividing them at -1 first. But so then the second one is going to be the limit as b approaches -1 from the right. And that is going to be the same thing, except that's going to go from b to 7. Okay. So now if we plug this in, limit as b approaches -1 from the left, that's going to be 3 times b plus 1 to the 1/3 minus 3 times -2 plus 1 to the 1/3. So here, if b is approaching -1 from the left, that's going to be -1.0000000, etc. So that's going to be pretty much 0. So that's going to be 0. This is -1 to the 1/3. That's -1 times that. That's 3. So that's plus 3. Okay. Now if we come over here and we're still looking at the limit as b approaches -1 from the right, and this is going to be 3 and 7 plus 1 to the 1/3 minus, and then this is going to be b plus 1 to the 1/3. So that's going to be 8. So the cube root of 8 is 2, and 2 times 3 is 6. And that's plus. This is plus. And now if we plug in -1 just to the right of -1, that would be negative 0.99999, which is pretty much going to make that 0. So that's going to be 9. And our last example of chapter 7, our last integral example, is a doubly improper integral. Ooh. Okay, so there's two different problems here. One is that as we approach 0 from the right, this approaches negative infinity. And negative infinity or positive infinity? That would be positive infinity, sorry. And then we also have an infinity here, so we have to separate that two ways. So first of all, we could split it up anywhere, so I'm just going to use 1. So 0 to 1 of x to the -1/2 dx plus 1 to infinity of this same thing. Okay, so on this side, I take the limit as b approaches 0 from the right, and I'm going to go ahead and integrate that right now. So add 1 to the exponent, that's going to be x to the 1/2 divided by 1/2 or multiplied by 2. And then that's going to go from -2, no, b to 1. Okay, so I'm just going to continue on this side for now. So the limit as b approaches 0 from the right, plug in 1, so that's going to be 2 minus 2 root b. Okay, so that's going to be 2 minus 2, and that's going to be 0.000 dot dot dot. So that's going to be 0 basically, and 0 times -2 is 0. So that's going to be 2. Okay, now over here, we're going to let the limit as c approaches infinity, and this should be the same, except now we're going from 1 to c. Okay, so limit of c approaching infinity, that's going to be 2 root c minus 2. And so if that's infinity, that's going to be 2 root infinity minus 2. Well, that's infinity. So 2 plus infinity minus 2, that's infinity. So that diverges. All right, so that's chapter 7.